So, Mikael, what do you want to do? Do you want to have people come to you? Do you want to? Okay. Okay, so traditionally we've had a mic stand with a mic on the top of it. The mic stand today is called Mikael.
Yes. Yes, Mike. So because I want to write down the name in Jabber, whoever's talking, so if people can come here, you know, they should flash me the badge. I will give you the microphone. If you don't have a badge, I'll hit you with the microphone.
Okay, so this is V6OPS. If you think you're somewhere else, you're in the wrong place. And is this on? That's on. Good. Okay. So now, agenda bashing. This is our agenda this morning. We've got two. We have an invited talk. We have two working group drafts. And then, frankly, we had some open space in the agenda, and we had a bunch of drafts that got very little discussion really on the list. And so I went ahead and put them in there. And if you don't like that, throw the eggs at me. I do have one question. Fred Templin, are you online?
Yes, I am, Fred. Do you hear me?
Yeah, okay, good. So it's 2:30 in the morning where you are.
That's correct.
Do you want to go first or do you want to go last? Take your pick.
I intend to hold on for the whole session, but if I were to go first, I think I might be a little bit more alert.
Okay, then we'll move you to the front of the list. I have one kind of opening chair comment before we get started, and that is that we're reducing the number of chairs.
Literally.
Literally.
You can have one.
So
I'll get to work.
Lee and Ron and I have been co-chairing this working group. Lee has become a busy boy. He's got a startup. So he's going to no longer be a chair here. And I want to thank you for your efforts.
Thank you.
So
You've made it easy.
okay, well, thank you much. So now what I'm going to do then, I'll have you go first, Fred. Hang on just a second, I'll get your slides up. What? That is not the right thing.
Fred, you look sleepy.
Well, I'm wondering what my computer is doing to me. Here we go. There we go. Okay, so Fred, you go ahead and tell me when to change slides for you.
Okay. We'll just start right into it, I guess. This document is called IPv6 Prefix Delegation Models. It was originally called IPv6 Prefix Delegation for Hosts, but we've had some discussion on the list that prompted a name change. Next chart. So the history of the draft is that this document has been around for some time now. The 00 was posted in November of 2015 and announced to V6OPS. We had a couple of draft revisions based on list comments. Then in July and August of 2016, the Internet Draft Review Team, which was part of the IPv6 administrative team at that time, reviewed the draft, and that resulted in the publication of the -03. Since that time, there have been additional revisions between August 2016 and October 2017, and we presented draft 15 at IETF 100. We received significant comments at working group session and on the list afterwards. And now we're at draft-19. This new draft version includes a version by version change log. And there you have the URL for the draft and the data tracker. Next chart. It's still pixelating on my side. Okay, now I've got the quick chart. So IPv6 prefix delegation entails the communication of a prefix from the network to a requesting router, a representation of the prefix in the network's routing information base, and the first hop router's forwarding information base, and then a control message service to maintain prefix delegation lifetimes. An example service is DHCPv6 prefix delegation. But we consider the case where the requesting router is a node that obtains a prefix for its own exclusive use. The thing's pixelating on my side again, so I'm going to have to go to... okay, now I've got it back again. So it is a node that obtains a delegated prefix for its own internal multi-addressing purposes, or attached a tethered Internet of Things. Next chart. I'm having trouble with it pixelating and not coming up fully that I can see it. So what I think I'll do is I'll pull up the PowerPoints locally on my side and I can see if I can sync up with you.
Okay.
You should be on a slide now that says Case 1 Classic Routing Model. Is that right?
That's correct.
Okay.
Do you want me to read the titles so that you can be sure you're looking at what we're looking at?
I think we're in sync, Fred. If I get out of sync, though, just let me know.
Okay, cool.
Okay. So Case 1, the Classic Routing Model. In this case, the network N delegates prefix P to requesting router R. R can subdelegate the prefixes from P to downstream networks or assign addresses from A sub I taken from prefix P to a downstream interface. And hosts H sub I assign addresses A sub I taken from P and may also further subdelegate prefixes from P on their downstream interfaces. Examples would be a cell phone with a tethered external network like Bluetooth, or a laptop with an internal virtual network of virtual machines. So if you look at the diagram on the right, you can see that the requesting router has gotten a prefix and has assigned addresses for itself on a downstream interface, and hosts on the downstream link have assigned addresses for themselves on their interface attachments to that downstream link. Next chart, please. This chart is Q2 weekend system model. In the weekend system model, router R can assign addresses A sub I to an internal virtual loop interface like a loopback without invoking MLD or DAT on the upstream interface. An example is any host with an internal virtual interface on which addresses can be assigned. Next chart. Case 3 is known as the straw-end system model. In this model, R can assign addresses A sub I to an upstream interface without invoking MLD or DAD. And example is any host that cannot assign addresses to any other interfaces beside the upstream interface. And this is exactly the case that we found when we ran OpenVPN on Androids. We found that if we got a prefix delegation from the OpenVPN server, the client could not assign addresses taken from that prefix to a virtual interface or a physical interface, and so it had no other interface to assign them to except the upstream interface. But once we assign the addresses to the upstream interface, then IPv6 applications work on the Android device just fine. Next chart. Changes since IETF 100. We changed the title from prefix delegation for hosts to IPv6 prefix delegation models, and that was based on list comments. We have a new section on address auto configuration considerations. It cites RFC 6434 bis, section 6, as the reference for auto configuration requirements for nodes. It acknowledges that subnet router anycast address must be honored. We've updated the figures to relax the strict dependency on delegating requesting router model, and that opens the possibility for prefix delegation service options that do not instrument the first hop router. But the networks must still somehow inject routing information for the delegated prefixes. Next chart. Now here is where we might be getting a little bit of a controversial section, is that we have a new section on prefix delegation services. This is based on list comments. This new section says, selection of prefix delegation services must be considered according to specific use cases. An example service is that offered by DHCP v6. An alternative service based on IPv6 neighbor discovery messaging has also been proposed, and you see a pointer to a document here called the PIOX document as a new example that's being considered. Then it says that other non-router mechanisms may exist, such as proprietary IPAMs, ID anime prefix management, and ID Sun CASM address pool management Yang. So what this section is essentially saying is that we're not only considering just one prefix delegation service, but we're leaving open alternatives for possible future prefix delegation services that might be published. Next chart. So the questions I have for the working group: do we want to remain prefix delegation service agnostic or focus on one specific service like DHCP prefix delegation? Then what do we want to call the end systems that receive a prefix delegation? Host, router, node, something else? And then the third point is, does the answer to question 2 depend on the weak host, strong host distinction as to whether we call it a host or a router or a node? And I think I'm out of charts now.
Okay. So, yeah, I asked you for a 10-minute talk. It's actually been about 10 minutes now. So I'm not sure we have time at this point to go to the mic and discuss these. What I'm going to suggest is that people please comment on these questions on the list so that we have that discussion and Fred can respond to it. Is that fair, Fred?
Sure, Fred, that's fine.
Yeah, okay. So I'm going to move ahead. Thank you for your talk. And what is this? So Pete, are you here? Okay. Can you make that?
Right. Hi, everyone. Can you hear me? More or less. Right. I'm Pete Stevens. I'm the director of Mythic Beast Limited. We're a small hosting company. And microphone, please.
Yeah, that's it.
Oh, it's on. Take it off.
I took turn the mic. This one was on when I was.
Is that better? Oh, that makes a big difference. Hi. Okay. I'm Pete Stevens. I'm the director of Mythic Beast Limited, and I'm terrible at working microphones. we've done a decent amount of IPv6 only hosting, which is why I'm here. We're a small hosting company, so most of the people who talk about V6 are kind of hyperscale, Facebook, Google size. We don't have as many servers as Google or Facebook, probably not even 1% of the number of servers they have, so we're a bit of a different use case. This has got lag. So, important question, what's wrong with IPv4? This is pretty easy. We used to have one IP per server. We now have one IP for every VM, and you pretty commonly get 50 VMs on a server, maybe 100. 100 IPs per server. Since then, we've started doing container rollouts. Our most exciting container rollout is now pushing 400 containers on a single machine, and therefore needs 400 network addresses. And we're looking pretty good at eating 1,000 network addresses per machine fairly soon, which is great because 1,000 IPs on the open market costs considerably more than the server. So we have a problem, which is we can't afford to use an IP for every container. Hello, Nat. What we'd really like to use at this point is some private IP space, ignoring the fact that that hard limits our company to 16 million containers before we have to start thinking even harder. So, you may notice the 7-layer OSI model these days, where you have a physical layer, and then we have Ethernet, and then you have a UDP layer that implements an overlay network, that implements UDP, that implements another overlay network for your container infrastructure, that might implement TCP if you're lucky, and then you've got HTTP on the top, and that's what the Docker kids call a router, and they start implementing other protocols on top of that. This is no fun. The brief economics argument, I'm sure you're well familiar with, which is I can turn up, go to write, and get a /22 of address space. I can sell my VMs at £10 a month, and that means I can build a hosting company that generates £100,000 a year, and then it runs out of IP4 addresses. And that's it for company expansion. Thank you for becoming a new player in the hosting market. Your game is over already because you can't afford a 24/7 ops team. So if IPv4 addresses were free, our life would be much better. IPv6 addresses effectively are free. So this leads to the obvious question, can I do stuff with IPv6 addresses? But more importantly, I'm good friends with the people at Raspberry Pi, and they like to remind me that an IPv4 address is now $24, according to IPv4 Market Group, and they'll sell you a computer for $5. You can have 5 computers. The computers are now cheaper than the octets. So, we have a problem that the address space is too expensive, and it's just an economics problem. It's not a technical problem. We can't afford the addresses. What are we going to do? So, we implemented V6 a while ago. Any of our VMs can talk V6 or V4. We give you a V4 address from the DHCP server. We give you a block of V6 addresses. We have this magical thing called Slack that gives our servers completely random addresses, which means we don't know where to send inbound services to, which is really annoying. And also, if you enable Slack on a hosting network, all of your customer machines enable a V6 address, use it for outbound traffic, all appear in the same 64, and then immediately get blocked by everyone else's mail server, so you can't do that. So that's not very helpful. You can use DHCP6, but that's a world of pain in its own way because the installers tend not to like it if your gateway address is not in the same 64 that you're trying to give to the customer. If you're giving every customer their own 64, you need an address on the router for every single customer you need, and it all gets really horrid. So the easy trick is just statically address everything. The next problem is your V6 only machine needs to have a V6 resolver in order to work out how to go and download an update. So we statically address, we use router advertisements to advertise out gateways, so that way if our router disappears, the advertisement goes away and it falls back to the other one. This is a really nice way of doing a decent level of redundancy for virtually no effort. The problem you get is most operating systems use a mirror service, and whilst the mirror director speaks dual stack, it doesn't know which of its mirrors are dual stack or V6 only. So it will hand you a URL for a v4 only mirror that you can't get to because you're on a v6 only machine. And on top of that, an awful lot of services on the internet don't have v6 either. So as a product, this is rubbish. Don't buy it. So yeah, it's really not very useful. So part of the problem, NAT64, skipping very quickly, we synthesize v6 addresses for everything we can go to, as your LAN does here. It works very nicely and solves a big chunk of your problems. So we now have outbound traffic, we can get updates, our server works. Unlike this clicker. Can I have my next slide? So inbound traffic. We need other people who don't have v6 to be able to see the stuff on your machine. So we have a central proxy service called proxy.mythicbeast.com. It's implemented with HAProxy. If you go to our control panel, you can just go and type in, this is my URL, this is my backend server. It auto configures itself and magically all of your stuff gets tunneled through. It accepts v4 and v6 and then forwards it onto the backend. It does HTTP and any service that supports SSL that uses SNI. Windows XP has died. We don't have to worry about things that don't do SNI anymore. Doesn't forward SSH, which is the really annoying thing. So you can't SSH into your v6 only server if you've got v4 only on your client. But from the point of view of giving services out to users, if it supports SSL, it works. If it doesn't support SSL, don't use it. Quite simple. So let's try that again. So this gives us an actually useful product. We've got a VM. It consumes one v6 address only. Has outbound traffic. It has inbound for SSL and HTTP. And you can host websites on it, like raspberrypi.org, which is done exactly that way and is one of the busier sites in the UK. So for Raspberry Pi, we've now got 40-odd VMs sitting at the back end that actually put everything together, that do HTTP and databases and memcache and all the different bits of their site. And the whole thing gets stuck together by the front-end proxy. And there's no v4 at all on any of the VMs. Because as long as everything uses SSL, it all works fine. So that's a useful product that you can do something with. I may get another slide. Thank you. So most of what we do actually is manage your VMs for you. We realized that as soon as we deployed a server that didn't have a v4 address, all of our management services had to support v6. And this was the kind of biggest bit of effort in making this go. So backup server, we just had to add a quad A record and then we could back up to our backup server. Prior to that, it turns out what happens is everything backs up through your NAT64 proxies, which gives you a really nice bandwidth graph on your NAT64 proxies. So yeah, you learn that one very quickly. Monitoring customer machines, we have to monitor the v6 addresses at the back. We had to explain to our control panel that it was allowed to talk to v6 addresses because a bunch of it's written in Perl, and until you have a version of libwww recognized that supports v6, that didn't work very well at all. Next slide, thank you. Where it got more fun is we use Munin to graph everything, upgrade Munin to the latest server to get v6 support, add v6 to the Munin server, all of your graphs break. That's partly because you've got to update the Munin config file on every single client to know that it can now talk to your v6 address. And also it has that entertaining syntax for a v4 address if you're also v6 capable. I think they've turned it off. They've turned it off because it's flaky. Right, I'll look this way then. Yes, that apparently is a v4 address embedded in v6, embedded in some escaping rubbish because Munin isn't very clever. Yeah, that was fun. But yeah, that was an extremely boring few days. But all in all, eventually it works. Next one. So we then had to go and update all of our code that auto-magically generates all of our management services so that it could correctly escape out to V6 addresses because they need square brackets around them when V4s don't. That's really annoying. Yeah, there were lots and lots of bits of our control panel where we'd asserted that a server had a V4 address that is an assumption that gets broken as soon as you deploy your first V6 only machine. Once you've done that, you then start turning V6 on by default for every single customer install you ever do. Next one, please. Another bit is every day our machines log in a whole bunch of data about what's going on. So if you've ever been handed a machine completely cold, where someone has said, I've got the server on the internet, I don't think it's working properly, you know about servers, can you take a look? You log in and you start typing things like netstat and what ports are open and what's my firewall configuration. We basically automated that and run those commands every day on every single server. And that means you can compare what the firewall service was doing before you rebooted the machine to what it's doing now after the person's just told you it doesn't work anymore, which is really helpful. Unfortunately, because this is also deployed, it uses the IP address as a key to work out which machine it's come from. On a dual stack machine, that makes everything much more exciting because you've got a bigger variety of IPs that stuff may come from. So we had to implement a load of stuff that would go and read the reports we got from them and start matching up the MAC addresses in the report we got to work out which actual server this came from, because IP address is no longer good enough at telling you. Next, please. We also have Jumpbox, which is how we log into things. It automatically works out which customer key you should be using when you go and log into a customer machine, because each customer has a different key. Now we've got multiple addresses for every target machine. Yeah, more intelligence required to deal with that. A good chunk of this is actually just that our code wasn't multi-address aware rather than V6 specific. It's just that in V4 land, no one can afford 2 addresses per machine, so we hadn't really had to deal with the problems. But the really nice thing, of course, is because our jump box is dual stack and everything we do on a customer server has to go through our jump box. It doesn't matter if I don't have V6 on my desktop at any given time, because in order to log into a machine, I have to go via our jump box, and that means I've got V6 into the customer server. Next, please. So, one of the things we're continually doing is improving our customer deployment for particularly managed customers. So ideally, we want to get to the point of you press a single button and up pops an entire automatically managed customer installation that does whatever they want. We got to attempting to do our next set of automation, and dual stack's really horrid. Having to do everything twice, set all of your firewalls up twice. Don't like dual stack. Dual stack's really painful. We concluded it'd be much easier to just do V4 or just do V6. But obviously, anyone who starts off V4 only is going to become dual stack. So we've got to take that pain anyway. And then we concluded that the easy solution to this was we just do V6. So if you set up a new managed system, it comes out without a V4 address. And at the very end, if the customer needs it, you can add a V4 address in and add your additional V4 firewalling rules. But it's now an assumption that every new thing we deploy is V6 only, and every new management service we deploy only supports V6, and we can just not bother supporting V4 because life is easier that way. So, previously mentioned, Slack is not very nice from our point of view. DHCP 6 is not that nice either. Link local, however, is great. Every machine starts up and it has a link local address. So what you can do when you first start a machine from an image is you can nip to a known link local address that you know will be present on the LAN, pull up a file that contains the entire config of how you're going to set yourself up, and then write all of your static configuration there. Yeah, it's a single HTTP call that you can do on boot up that writes all of your config in, and the automaticness of link local is brilliant for us. And it means we don't have to deal with the HTTP 6 or Slack, both of which are horrid, and I don't like either of them. So that's definitely an improvement from our point of view. Sorry if either of you, anyone here works on the HTTP 6 or Slack. Next, please. So the next question is, how do you persuade the customers to buy this? Because from our point of view, this is the whole purpose of this is to be able to sell services to customers that don't consume V4 addresses. Until we've sold a service that doesn't use a V4 address, we haven't achieved anything at all because we still have a hard limit on company expansion, which is running out of V4 addresses. or slides for that matter. So the first thing we concluded we'd do is we itemize V4 addresses. If you have a V4 address on a service from us, it is itemized on your bill. There is a thing that says you are paying £20 a month for the V4 address. This is brilliant. Accountants do not know what IPv4 addresses are, and accountants do not like paying for things they don't understand. Yeah, £20 a month would be quite exciting for V4 addresses. Yeah, £20 a year, sorry. Yes, so the accounts departments and the billing departments mail us back, and they say, why am I paying £40 a year for two IPv4 addresses? What are they? Do I need them? And if you go back to the accounts department and say, don't think so, the accounts department goes to the technical department and they say, why are we spending £40 a year when the company sells it to us, say we don't need it? And this gives your technical department two choices. One of them is they can explain to accounts why they want to keep their V4 addresses, and the other one is they can migrate to V6. Techies hate the accounts department. They really hate them. So that is an astonishingly powerful motivational tool. And it's not about the money. It's about, we just hate accounts. So next, please. So that genuinely does work. Similarly, the bit that works equally well when deploying new services, you turn up to us as a customer, existing customers turn up and they're like, oh, I need a new server and some V4 addresses. It's like, oh, sure, you can have a new V4 address. Go and fill in a purchase order from accounts to get a V4 address, or have a /64. What do you want to do? It's like, people shiver. It's like, oh my God, I've got to get 20 quid out of accounts. So that's really good. Bureaucratic hassle is way more effective than financial incentives. Customers. We've got a fair few technical customers who like IPv6, want to learn stuff about it, or increasingly would be embarrassed that the fact they don't have V6. Since I first gave this talk, that's now expanded to include things like the V6 Council in the UK Network Operators Forum, the London Internet Exchange, and so on. We've had a few DNS Anycast services because it turns out to be relatively useful for some reason. And the rest of them are actually non-technical managed customers who don't know what a V4 address is and are quite happy that they haven't bought one. And actually, that's the real win, because if we can sell to those people, we're really getting somewhere, because it means we're moving towards a V6 only future, and the end users don't know, and the whole thing's transparent. So, next, please. So the conclusion here is dual stack is rubbish. My view is if you want to come up with the dumbest migration plan to V6 you can imagine, it is everybody becomes dual stack. When everybody is dual stack, we can deploy V6 only and start turning V4 off, because I have a friend called James. He's really bloody minded and he doesn't want to deploy V6. And if I have to wait for James to deploy V6, it's never going to happen. So basically, it's much easier to say we have V4 over there, we have some dual stack that talks both, and we have V6 only over here. And this is the world we're actually in, because there's increasingly large piles of V6 only. And we have some translation in the middle, and then it's just make it easier to deploy into V6 land and harder to deploy in V4 land. And eventually everything will gradually move over. And what goes with this is the thing that persuades you not to go and deploy things into IPv4 land is NAT is horrific. And particularly when you look at anything that goes across multiple sites. So at the moment, the DevOps solution to dealing with the fact that NAT is horrible is if you say to them, we should have a split site solution so that we can do a failover in the event the data center fails, is to automate their entire config so they can rebuild their entire system in a new environment, rather than have to deal with the fact that you've got to join a private network that doesn't have a flat LAN. Because VPNs are nasty, and you need to get the networking engineering team talking, and the networking engineering team don't talk anywhere near as fast as your Puppet code, and so on. So dual stack is horrid, NAT is horrid. And so, don't deploy dual stack if you can. If you can avoid doing dual stack, avoid it. Just deploy V6 only, and narrow down all of your V4, V6 things to the smallest number of machines. And primarily, I'm really sad to say, the main reason I want to do V6 is it's just not as horrid as NAT. Yeah, that's it. It's not somewhere I want to be. I'd really like to just live in a land where V4 addresses were free and infinite and everything worked first time. But no, it's basically NAT is so horrible, I have been prepared to deal with a bunch of the nastiness that's V6. So, which is how I got to where I am. Next, please. So, next question, does it actually work? Is it viable to try and deploy things if you don't have v4 addresses? Everything needs to support single stack v6. In our case, we substantially reduced the scope of the problem because we're a Linux shop. We run Debian, Ubuntu, and CentOS. And that's it. So Windows doesn't support v6 only. Don't care. Don't know. FreeBSD. Don't care. So yeah, we've substantially cut the complexity there. We give each customer a /64 of their own, and this is a requirement because everybody else filters things like mail on /64 boundaries. So if you have one /64 for your entire subnet in your data center, one of your customers sends spam, nobody can send email anymore. That's really annoying. So, and obviously the incentive here is the customers have to have v6 or our managed services don't work anymore. So that comes through. Next, please. Next one, thank you. So we're a hosting company. Most people run websites. That's what our customers do. So we have the LAMP stack, Linux, Apache, MySQL, PHP, or Perl or Python, or other scripting language beginning with P. No Ruby, fortunately. Awesome. Yeah, so that stack works pretty well. All of those applications support v6. Everything works. You can substitute Nginx for Apache if you want to, and everything continues to work. And you can substitute Postgres for MySQL, and it all continues to work. So we started with Raspberry Pi in 2012. That was the first one we did. And we made all the backends v6 only. We deployed WordPress, which is a gigantic pile of PHP increasingly improving quality, but it has had a lot of scope to improve from where it started. So the WordPress core works absolutely fine. WordPress has 1,000,001 plugins, which are extremely variable in quality and may not work v6 only or an acceptable speed on a website that anybody ever looks at, or in fact at all. So one of the biggest problems you have trying to work out why your WordPress plugin doesn't work in your v6 only environment is the failed assumption that it works anyway. So yes, next please. So yeah, the one that bit us first was one called Login Lockdown. Login Lockdown is a nice little plugin that spots people attempting to brute force passwords to get into the admin control panel and blocks them. And it has a lovely feature, or did at the time we wrote this, which is if you block a v6 address, it treats that as a match for the internet and blocks everybody from locking in entirely. So 3 failed attempts to log in over v6 and your entire WordPress site is now off. But fortunately, miracle of open source meant that we forked it, wrote 3 lines of code, and then just re-uploaded it again, and all of our problems went away. So that was nice. Next, please. Other plugins, WooCommerce for selling stuff, that works fine. Gravity Forms for having fill-in forms, that one works fine. Supercache, the one that makes WordPress actually work fast enough that more than 3 people can look at it on the same day, that one works fine too. Search engine optimization, yeah, that works fine. Spam filtering, as long as you've got your NAT64 proxy in, so it can call out to the spam filtering service that doesn't support v6, again, fine. Basically, all the well-used plugins, they just work. You can reliably bring up WordPress and tell the customers to go and install any plugin they feel like. And if the plugin doesn't work in a v6 only environment, it's probably because the plugin doesn't work at all. So yeah, that's pretty good. Next, please. So we grew from that and we do WordPress as a managed service. So we basically apply rights rules, give us a technical justification in order to get an additional IPv4 address, except that we count from 0 because we're computer scientists. So by default, you get 0 IPv4 addresses and you have to give us a justification to get the first one. And they're extremely rare. Most of our managed WordPress services sit on v6 only VMs and hide behind our proxy service. And most of the customers either haven't noticed or don't care or don't know. So that's going well. And at that point, I've successfully achieved something. I can continue to sell managed WordPress services in the event that no v4 address ever becomes available. And that gives us a path to grow our business. Unfortunately, it means all we ever do is manage WordPress, which is not really the business I wanted to run, but it's something, right? So yeah, we've got something. Next, please. So From there, we started to expand out and start looking at other things. So MediaWiki, we've done some managed MediaWiki for people. Again, it all works fine because it's a Apache LAMP stack. Internally, it uses Node.js and something called Parasoid in order to have the nice graphical front end that mangles all of your HTML really badly. Apparently that's important, but yeah, internally it talks to port 8000, and you have to fiddle a config file to make it spot that you've got v6. And the UK Office Wiki is built on top of that, and that all works fine. Next, please. Let's Encrypt. Let's Encrypt is a brilliant solution because, as I said, you have to use SSL in order to sit behind our v6 proxies. SSL is now free. And thanks to Let's Encrypt, it's also now really easy, and you don't have to continually renew certificates and copy files around the place and get people to reply to emails because nobody replies to their email. So yes, it's great. It works out of the box behind our proxy. That all just worked absolutely fine. There's no difference. It now also does pure v6 as well. So if you decide you don't even want to offer v4 at all, you can still use Let's Encrypt and have SSL. So yes, Let's Encrypt is one of the things that makes this much easier because it removes the customer objection to having SSL. So yes, we like that. Next, please. London Internet Exchange. So they've just rebuilt their website. They had a horrid content management system that was very hard to update and losing security support. They said, should we base it on WordPress? And we said, yes, that's what all content-driven sites are basically built with. Your life will be easier. So we manage it for them. We forgot to turn the proxy on, but the London Internet Exchange have v6 everywhere. And it was actually 28 days until anybody noticed that they didn't have any v4 at all on their dev website when someone tried to access it from their phone, which is an actual sign that the v6 adoption is successfully taking off. We're really making progress. So yeah, we're getting there. Next, please. That said, rpf.io. It's a URL shortener, which is used by Raspberry Pi. Basically, they used to use Bitly, which is of course a very well-known URL shortener. Basically, Bitly is a service that writes a htaccess file with some redirects in it, but has a slightly nicer user interface. Next, please. So we emailed them and said, can we use our own domain name? And they said, yeah, it's $695 a month. And Ben, who was their manager, said, did you miss a decimal point? Did you mean $6.95 a month? So in the true open source tradition, we decided not to pay $700 a month for a trivial service, and of course just deployed our own. Next, please. So yeah, there's a little PHP application that does this. It absolutely works fine. If you don't like PHP and want to do it in Python, you can off-wrote one as well that also works fine, so you can use that instead. Alternatively, yeah, but there's loads of them. Next one, please. Etherpad, open source alternative to Google Docs. Shared document editing written in Node.js. Listens fine, requests come in. We forward traffic to it. When it makes connections out, it's a bit special. Next, please. So you've heard of Happy Eyeballs. Happy Eyeballs is where you look for v6 and try to connect to v6, and if it doesn't work, you go back and connect to v4. Node.js is a bit more exciting than that. So it does a quad A lookup, and our NAT64 resolver gives it a v6 address for the service it's trying to talk to. It then does an A lookup and gets a v4 address, and then it tries to connect to the v4 address, fails, and stops. Because it never tries to connect to the v6 address if a v4 address is present at all. Ladies and gentlemen, do not write your own DNS resolver. People who work for Bind or whatever, you're accepted from that rule, but everybody else, don't write your own resolver. Okay, so, and this is of course a pain in the arse, because for those of you who know anything about Node.js will know that it repeatedly downloads all of its packages from completely untrusted things in the internet and deploys remote root to your machine on a regular basis, which is vital for its operation. You've got to really watch out for people deleting packages and replacing them with malicious ones. So, but it turns out there is a really easy workaround for this. So if you put the quad A record in the etc host file, it turns out the lookup doesn't succeed getting an A record, and then it connects to v6. Because obviously you'd implement v6 support and then just switch it off. Now it connects outwards. So next, please. So Again, conference booking system, Indico, we've done a few managed installs of those. Node.js, same set of problems. Adds in Redis and Memcache. That's exciting. I'd use one or the other, but there you go. Cache early, cache often. So yeah, we've got a few Indico installs for managing conferences. They all work fine in the V6 only environment. Next one. Sugar CRM. Those of you who don't like Salesforce, this is a gigantic CRM system. So it's, again, Linux, Apache, MySQL, PHP, but adds in Elasticsearch, which is written in Java, which sits on top of Tomcat, and Memcached. We're running split site instances because salespeople have no patience if their website is down. And so they're high availability, you can flip over between them relatively quickly. And because Elasticsearch and Memcached don't support a multi-tenant environment, we need to have a separate copy of Elasticsearch and a separate copy of Memcached for every single customer that's using Sugar CRM. So we decided that the right way to do this was to build each one in its own container and put a single container that contains absolutely everything you need for a Sugar CRM stack. Next, please. So yeah, every time they have a new customer, they fire off a script, up come 2 containers. They each get a V6 address and only a V6 address. They get a little firewall that says you can talk to the proxy at the front and each other, and that's it. And MySQL replicates across the 2. All the internal traffic is SSH or SSL based. And we don't need a VPN to connect these 2 things together, even though they're in different buildings and different routing domains, and there's no layer 2 between them. Which is a massive saving in networking configuration faff. We can just say that connections work. Go ahead. Next, please. Originally, they internally built a prototype that used Docker for all of the bits and pieces and sat on top of CoreOS and did the whole, oh, my container has fallen over, automatically deploy a new one somewhere else. And then you deal with the fact that Docker doesn't really do persistence, and you've got a MySQL database that contains your customer's data that's not allowed to lose more than a few seconds worth of data. And yeah, just far, far simpler to just spin up a full stack for each user and give it a V6 address and assume that networking works, and you don't need overlay networks, and you can use SSL everywhere. So yeah, way, way simpler. Next, please. Less good news, Hadoop. Hadoop doesn't work V6 only. It's improved. It used to be the case it didn't work if you had a linked local address on your machine. And the install instructions told you to fiddle syscontrol to turn V6 off entirely before it would start up. So it's improved. But yeah, we've not yet put enough work in to try and make Hadoop work V6 only. I'm told Facebook have it all fine on their internal infrastructure, but the code isn't yet public. I've not looked at this for a while. I may be out of date, but we have considered actually maybe the really hacky way to do this is to put a V4 and V6 tunnel for some RFC 1918 space and deploy a complete set of forwarding routes to every machine. But to be honest, at the moment, I have too many other things to do to really worry about Hadoop. So next one, please. Shared web hosting. Joshua is 16 years old, and he started a free service called Gwiddle Co UK to give free web hosting to school kids to try and teach them all about the internet. He's got, I think, a couple of thousand end users now. And he came to us and said, my free trial on generic cloud service of choice has exceeded and they're going to bill me lots of money. Would you like to support this because you support Raspberry Pi? And we said, yes, we'd like to support that. We think that's great. Have a bunch of VMs. You can't have a V4 address. This is an educational project. This is how the internet's going to be. Learn. So yeah, we've got well over 1,000 customers on that, school-age children who are already deploying things to V6 only land where V4 doesn't exist. They're kids, and they're ahead of many people you find at conferences, and they're children, okay? Be scared for people's jobs, okay? Next, please. I showed you earlier the picture of the Pi Zero. That's the cheap one. This is the really expensive model. The Raspberry Pi in there, each one of them costs $35. So they are more expensive than IPv4 addresses and are probably going to remain that way for at least another 6 months. Basically, that is what we call our Pi rack. So we've deployed Raspberry Pi attached to a Power over Ethernet device. As you can see, they sit 3 deep. You get them 2 high in 3U of rack space. You can put 2 of them in back-to-back into a rack, and that gives you 108 Pis in 4U of rack space, including the Power over Ethernet switches to make it go. Scales up to 1,000 dedicated servers in a single rack, which is expensive in V4 space. So that's what we did, and we thought, how are we going to do this? A very substantial part of our cost is the V4 addressing. Next, please. It looks pretty nice. It's a couple of watts per Pi. It's all net boot and Power over Ethernet, no SD cards. All goes nice and straightforward. And with the new model that was launched on Wednesday, when they make the PoE adapters, we should be able to increase that density by a further 50%, which makes it even more attractive. Next, please. So we came up with a brilliant idea that we give you a little bit of RFC 1918 space in order that you can get to the NFS server and boot, because the boot ROM doesn't support V6. And Gordon's not going to make it support V6 because he's only got 32K of RAM and it's already a bit full. So basically we give you a little V4 boot so you can get to your NFS server and get your kernel, and then everything on top runs V6. And then we thought we'd have a tagged VLAN that you could expose a V4 address to each Pi, which is a brilliant idea apart from the fact it doesn't work. And basically, the boot ROM is, the new Pi has a much better boot ROM. The old one that was available has a number of really good features, which is it says, I'm a Raspberry Pi, here is my DHCP request, please give me the answers I'm expecting, and if you deliver it any packet other than the answer, it crashes. That didn't work very well at all as an idea. So every single Pi has its own VLAN in order that we can guarantee it will not see any packet other than the one it's expecting in its boot process. And if we want to give address space to every VLAN, we're looking at a /30 of space, which is 4 IP addresses, which is now, $100 of V4 spaces to switch on a $35 computer. This is nuts. So next, please. We could do a /31, we could proxy ARP, there's a whole bunch of horrid stuff we could think about doing. Alternatively, we could say it's an educational platform, you're getting V6 and live with it, which is what we did. So when one of these things turn on, it gives you a port forward so you can get in over SSH, and then other than that, it sits behind our standard proxy service for all of your other services, so you can do HTTP and anything that supports SSL. And again, if you want to run a service that doesn't support SSL, wake up, support SSL. Don't deploy non-SSL services anymore, ever, anybody. Thank you. Next one, please. So that's my summary. Does anyone have any questions?
On the out there in the great wide world, are there any questions?
Hello. No, yes, there was a question from the room. P. Hessler. How many customers insist that they still have users only on IPv4, so they can't go to IPv6 only?
Okay. Well, I'm not sure exactly what you mean by customers that have only IPv4. Do you mean VMs that we host that only have V4? Or, because I mean, obviously 80% of the internet only has V4, but they can all use services on our V6 infrastructure because there's a proxy in the way. So, you know, V4 is never going to go away as far as I'm concerned. Some people will never leave it, and that's okay. They can stay there. I mean, I guess the point I've been making is I've deployed V6 only because it solves a bunch of problems I have, which is I can't grow my company. I don't really care if everybody else deploys V6 or not, because it doesn't matter, because I have a proxy layer to interpret the two. It just helps when other people deploy V6 because more things can go straight through.
Yeah. So the question was now changed to how many add an expensive IPv4 address? How many have that itemized?
So the vast majority of unmanaged VMs, so people who just buy a VM, have a V4 address. There's very few of those that are V6 only. When it comes to our managed VMs, it's probably less than half now have a v4 address, but that's not strictly true, because v6, because your addressing is free, frees up your design constraints, so it's much easier to deploy more servers to run the same thing. So whereas in v4 land, you might go, I could deploy everything on one machine with one IP, and then it will all work. And as soon as you go, oh, I want to have 5 machines and microservice my things out, it's suddenly, oh, I've got to build a private address space. Whereas in v6, that's not a cost. It's not a time cost. So it's much easier to deploy more things that are v6 only than it is with v4. But yeah, it's probably around half of our managed services have a v4 address still. And I don't know what fraction of those we could persuade to throw them away, but probably a fair few. I mean, a bunch of those services date back to before we deployed v6 at all on our LAN. So there's obviously history and legacy of new stuff we roll out. I would imagine, I think it's around half, pretty much.
Hi, Lee
Hi.
Howard. Thank you very much for doing this. I've been wanting to see more of this, more about specifically Mythic Beasts for years. How much of you, so there's some custom code that you've had to write, so for your provisioning systems, for instance. How much of that have you made available as open source, and how much of it is proprietary?
So the stuff that runs our network is proprietary, essentially. That only exists for us, and probably take a bunch of scrubbing before we'd be prepared to release all of it. Increasingly, we try and turn things into APIs that people can use. And I mean, I'm not actually certain all of our decisions were that smart at the time we made them either. So we spent a lot of time. So one of the things you can do with our VMs is you can boot off your own install media. And for a long time, that's what we did. And one of the worst things we've discovered is, whilst operating system support for v6 is quite good, the installer support is horrific.
Oh, yeah.
And so that particularly, so if you've got a pure Slack network, it works fine. But we can't deploy that in the data center because it gives everyone an address. If you do DHCP6, by default, it won't pick up route advertisements, so you don't get routers. But you can hand it a gateway, but the gateway has to be in the same 64 as the DHCP6 server, which means our router has to have an address that matches every single server we deploy, and that's just ridiculous. And really what we want to do is hand you a /64 of your own with a gateway address that's outside of it that you get a static route to, and explaining that to a DHCP server that will give it to the installer that the installer believes is a valid method of networking is just way too hard.
So Lorenzo?
Thanks for presenting in such detail. It really shows that sort of most stuff just works at this point, most stuff. I wanted to go back to your point where you say it's depressing that, the only reason to do this is that NAT's so bad. I think that's not depressing. I think that's just the way it is. And I think what you're doing is you're showing that there is, in fact, a cost difference. And that's really the only thing that matters. It costs money to do V4. It's not really necessary for most use cases anymore. The market will sort it out. And I think it's great to see how far we've come, because that wasn't true, 10 years ago or 5 years ago. And it's great to see that it's true now, at least for you.
Thank you.
Okay, Awal? I don't know how to pronounce your name, but we've got a person on the Great Wide World. Okay, Meet Echo, I'm not hearing any sound.
Oh, well, your question?
Okay, Awal, we're going to have to come back to you. We can't hear you over Meet Echo, so we're going to have to come back. Okay. And I don't see anybody else at a mic here in the room, so thank you very much, Pete.
That's okay.
Okay. Okay, so now the next thing that I've got up, Russ, you're not in the room, are you? Okay, so Russ White and several people from LinkedIn and such have been working on an IPv6 router specification that they hoped would be comparable to RFC 1812. I don't think they've quite gotten there. But so he's in a competing meeting, and let me walk through his slides. What he's trying to do is take advantage of the transition to think through changes in network architecture and provide a set of what he says here are suggestions. Title of the draft is requirements for various things. Now, what he's done recently in response to comments on the list and off is he's changed language regarding DHCP and Slack, modified some of the language around ICOMP, various other changes, and most importantly, gotten rid of the RFC 2119 language, which basically means that he changed from uppercase to lowercase. I think the meaning of the words is still about the same, but he's a little bit frustrated. There have been concerns on the list and at breakfast this morning talking about the scope of the draft. He has asked for text regarding how the scoping should be done, and he hasn't gotten something that works for him. And so he feels a little bit stuck in that regard. He's also gotten comments that are pretty negative, that they don't think the thing should be a current draft. So his question at the moment is whether he should simply withdraw the draft, or is there more? How does he get the draft to something that is going to be useful in the working group? And what I thought would be most useful would be to simply have a discussion of the draft here in the meeting. And give him a way forward, either that or tell him that there is no way forward, and have him withdraw the draft. What do we want to see happen with the IPv6 router draft?
Thank you. Barbara Stark. So I actually think it really is for me about the scoping. And I proposed some scopes, which apparently he was not happy with. What I would like is if Russ were to specifically say which routers he has a problem where he needs to solve. That is, scope it to the set of routers that he specifically wants to solve rather than trying to solve world hunger, which isn't going to work because the draft simply cannot be for all routers. It will be totally useless if you try to make it for all routers. But if he scopes it to his routers of interest, which I don't know what they are, that would be good.
Lorenzo Colletti, yeah. Same thing, really. I mean, I think, like, realistically, every IPv6 implementation is capable of forwarding packets. So, like, this thing applies to basically billions of nodes. And, like, having a one-size-fits-all thing just doesn't work, I think, right? And, so the IETF doesn't really do shopping lists, and this is kind of a shopping list document. But I think if you want to do a shopping list, you need to, like, decide what you want. It's an enterprise router or it's a backbone router, and if we put in some categories and say, look, this is this is, these requirements are common to everything, right? You need to be able to forward packets. Okay. You need to be able to send the ICMP packet 2 bigs. Okay, right. Those are common requirements. They're in the RFCs, but that's fine. We can say this is necessary for stuff to work. When you go in and say, well, these are optional things that aren't required by standards tracked RFCs, they're not in the node requirements, which, again, like what's the duplication between this and the node requirements document is not really clear. But let's say that there are things that are optional, they're not in the node requirements, then you say you have to have some categories of things where you can say, well, for enterprise routers, you need to do this. And for, portable routers, you need to do that. And for sort of home routers, you need to do that. We already have one for home routers. It's called, 7084, right? And we're pretty happy with that. That's not a shopping list, though. It's worth looking at. It's worth noticing that that's actually written in the sense, most of the requirements 7084 are, if you do this, then you must do that. They're not of the form, you have to do this, 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 and this. And every time someone's tried to propose, oh, you need to be able to do DS Lite, and you need to be able to do 6RD and things like that, those attempts have foundered. So, like I said, the only ideas here are to define some profiles and see if we can get consensus on the sub-profiles. We can probably steer clear of most of the contentious points and say, well, maybe no one's going to disagree with enterprise router requirements. Maybe that's going to be fine. But just having one size fits all, I don't think it's ever going to fly. Oh, and we had this problem with the mobile device node requirements, and that was pretty painful and long. It took a long time for that to fail. And I don't think that's in anyone's interest, right, to do it again.
Tim Jones, so I think I agree with pretty much everything Lorenzo said there. Co-author of, obviously, a slightly different shopping list, the 6434 BIS. There are a number of things in there that do apply to all nodes, but we do have essentially quite a few if-thens in there as well that are conditional on the context. Also, 6434 BIS doesn't stray too much into router territory. It's largely about hosts as nodes rather than routers. And in our minds, this document is kind of in some ways complementary to that, and it's talking more about the routing side. In fact, we did do a consistency check. I think Lorenzo hinted at how consistent the two are there. And we found maybe 7 or 8 differences, and we've brought them together, all but a couple of those things, by changing one or the other. So I think in terms of what's stated in them, they are pretty consistent. The only one that isn't consistent, which I guess Lorenzo will love, is the router one says must do DHCP v6, and the hosts one says should do DHCP v6. So that's the one little discrepancy there. I think in terms of the document itself, I really like the way the document's written, the router requirements. I think the first 2 or 3 sections, I don't remember the exact structure, are a really nice discussion of some of the things you should be thinking about if you're deploying these things. And I think that's really excellent stuff to take forward. I think obviously we can have comments about whether the rest of it applies to selective deployment scenarios or not. But I would hate to think the whole thing's thrown away with all that other good material in there just because of the whether we can't agree to set a context or not. Clearly the home routing stuff is reasonably well covered by 7084, but it seems to me that some extra wording on the context and a few more if-thens would save the document. I think it'd be a great shame if we lost it.
Yeah. So hang on a second, dealing with some technical things. Now let's see. Okay, so this actually works. For a while, I used these and they didn't work. Okay, but this is working. Thank you. Okay, good. Okay, so do we have other comments on the IPv6 router draft? Seeing none. What I'll do then is I'll recommend to Russ that he listen to the recording of the meeting, and of course we'll have the minutes. So with that, Jen. So yeah, you want that one.
Section version 0.
Well, you were doing this.
Cool. So yeah, version 02 actually of this draft. I'm going to be quick.
Okay.
Is it me or?
So, but it doesn't work when you click?
Can you push the laser button to make sure that the battery works at all?
Well,
Yeah.
it works just fine from this far.
Okay,
away.
just me. I shouldn't be touching this thing.
Okay.
It's just 2 slides. Probably you can just
Yeah.
go to the next slide for me, please.
Okay, that works. Whatever.
Okay, yeah. So since last IETF, I made some changes. So I added the section about what to do if uplinks are flapping, because obviously, yeah, it would be probably a good idea of deprecate and undeprecate the prefixes every time uplink goes down. So probably something similar to BGP damping should be implemented. And I fixed some typos and a bit clarified the situation with intra-site communication in case of total uplink failures. So yeah, some systems definitely use preferred IPv6 addresses. At least some applications on some system I tested do use preferred IPv6 address if it's the only IPv6 address available. So it's not doing fallback to v4. But there are some suspicions that it might be actually application dependent. So the recommendation is if the site does require intra-site communication in case of multiple uplink failures, it may be worth considering either increasing number of uplinks or use ULAs or do something like that, yeah. But again, I think the goal of this draft is to provide recommendations for real small sites. We just need internet connectivity in most cases. If your topology is really complex, then yeah, probably it's not a solution you should be implementing as it is. So I have not received too many comments since the last update. And so I would like to ask working group, any suggestions to improve comments, or maybe shall we try the last call? Because I know people normally read draft when they're in the last call. And I really want you to read this draft.
Thoughts? Thank you.
Tim Jones. So I read this and I think it's some of the improvements you made are good. I think it was good in its previous state, so I'd very much like to see it advance. I think it's very useful. You hear a lot of comments from people that want to do sort of tiny network multi-homing, that there are things that just don't work, and having this quite practical advice I think is really useful. Just one question from the 6434 update point of view. In there, I mean, part of this comes from section 5.5 not being widely implemented. So in 6434, we currently say nodes should implement section 5.5. Should we make that a must, do you think? So,
no, I think the multi-homed host RFC are already saying that host should track that information. Yeah, so I think should is good enough. But again, this particular draft, not the big one, which is 50 pages long in the routing working group, right, is something which documents current solution, which I can deploy right now, right here, right? Yeah, so if I know
it's not really a question about your draft because that kind of sidesteps that problem, but I'm just interested in your opinion as to whether we should leave that as a should or make it a must, since it'll be discussed tomorrow.
I don't know, because I don't know if must is too strong, because I suspect there might be, I don't know, hosts. Well, would people do it if you say must? Would be really much different.
What's the rationale of the IETF as a whole if you say, well, people do things if you say must?
Well, generally speaking, when I use the word should, I'm saying I would like to say I'd like to say must, but I think there's a case where you wouldn't want to do it.
Yeah.
And so now let me ask, are there cases where you wouldn't want to do that?
Well, it would seem to me that you always would, unless you know the node will never be used in a multi-homed environment where it will have to pick between two exits and work well with two exits. Maybe that's something to discuss in 6 months. Well, but while Jen was up there, and in this draft it says part of the rationale of this draft is that 5.5 isn't widely implemented. Then, that's chasing the problem up. Okay.
So you go ahead. I need to.
Lorenzo Curry, yeah, Joe, let's go for last call, ship it, get it done. The only thing that I would add to the document if possible, but don't hold it up for that, is to explain how this is basically equivalent to IPv4 plus NAT, because I think the failure modes are either exactly identical or pretty much almost the same. And so it's true that this doesn't do perfect multi-homing, but neither does NAT, right? In v4. So, I don't think it has a section about this.
So I think I can remember if I copied it from the bigger draft saying like in v4 you solve it with NAT, in v6 because we do not want to do NAT, we're trying to find a similar solution. Okay. You're right.
I think it's worth pointing out that even like when you solve it with NAT, a bunch of stuff doesn't work.
Yeah,
and
session
it's the
does
same
not say,
stuff that doesn't work here. That's
okay.
That's the only thing.
Okay, I have a section for like solution limitations. I think I'll just add session there. It doesn't save your TCP session, for example, in case of failure, but neither do not. Yeah, okay.
Yeah, because I think the goal of this was to say, look, this is actually possible today if the network supports it, and just another thing about this sort of 5.5, I can't remember. I mean, like this is sort of swapped out in my memory, but I think we talked about that a long time ago. You and I, Jen, about whether 5.5 needed to be a must. I think that the conclusion that I had at least was that because 5.5 doesn't exist right now in most hosts, basically what we're down to is we have to change the hosts anyway. And if we change the hosts anyway, 5.5 isn't actually the best thing that we need to do. There need to be better things, I think. Right now I can't remember what the better thing was going to be, but I think...
Yeah, I think we had some discussion at Berlin. Yeah, so probably by the time when we can get 5.5 and a significant number of hosts, we might be able to do something. I don't like MPVD or something. Like
right. Yeah. So that was it. Basically, if we were doing right, exactly. So if we were requiring host changes anyway, then we might as well do something that really solves the problem, because 5.5 is kind of a hack anyway. Really, it sort of kind of helps, but not that much. I think that's where I was ending up. Yeah.
Yeah, Tim Chan. So I think I agree with what Lorenzo said there. So 6724 as an update was probably 2 or 3 years ago now. And at the time while we were doing that, this topic came up and we thought, well, let's add this extra thing in there to make things slightly better. But I agree, it's not by no means perfect.
I'm Jim Metat here. First of all, I'd just like to say I've read the draft and I didn't find any problem. So I think it's basically ready for last call. And secondly, regarding the 5.5 address selection rule, I'm wondering that newer implementations may actually be supporting it, given that, for example, Happy Eyeball version 2 is doing something quite complicated. So I would not be surprised if there's actually an implementation of it. I understand, even if there is, it doesn't make the main point of this draft, but I'm just wondering.
So like I know that significant number of devices in my network do not support them, and as a result, I just can deploy solution which will work for like 30% of devices in my network, right? So, and again, this is about I can do right now, right? Not in 2 years, 5 years. It's what could be done now without,
This is Barbara. I did look it over, and I think it should go to last call. I liked it.
Hello, Julius Krobacek. I'm wondering if I've missed a document somewhere. I've searched, but I couldn't find it in a review of which implementation supports 5.5. Which implementation support 5.5? Has anyone done the work of finding out?
I think Windows supports it. Yeah, Windows
Only
support.
Windows?
Yeah. Yeah, I like.
Okay, but a list of
I know implementations which do not.
Yeah.
And I know. Yeah.
Okay, that answers my
It's,
question.
No.
Hey.
Okay, thanks, Jen. So I'll open up a last call on the list, probably starting this weekend or something like that. When you comment, and notice the when, not if, I'd like you to tell me whether you think there's utility, and which is to say, if you have no negative comments, I still want a positive comment saying that, you know, you're ready to go with this. And if there's any issues, of course, I want the issues raised. So it'll be a 2-week last call, and I'd encourage everybody to read the draft and comment on it as it stands. So now, Mr. Ficola. Tell me this is working. Okay. Yes, it works.
Thank you. Okay, hi. This is a presentation about the application of alternate marking method to IPv6 scenarios. I don't know if you are familiar with these methodologies. So the RFC 8321 has been just published. And okay, this is just to give you a quick view of this methodology. The method is based on alternate marking technique. So we can use 1 bit, 2 bit, or the change between 2 values, for example, the label we can use. And so the packet mark is changed between 2 values or 2 bits, so red and blue. When the red packet counters are running, the blue counters are still, and vice versa. In this way, you can take the counters in the following marking interval in order to have the number of packets of the previous block. So in this way, the packet loss calculation is very simple because you can compare the number of packets for each block that is identified by a color. Also, delay and delay variation can be measured. What are the main strengths of this methodology? So it works on real production traffic, so there is no injection of synthetic traffic. It works even in case of out of sequence. In fact, if you have reordering at the edge of the batch, you can take the counter after a while in the following batch, so you don't have a problem of reordering. And it can work on not synchronized at the network because the alternate marking change is a sort of auto-synchronization signal over your network, so you don't need a strict synchronization. And it works without OM packets, so the insertion of OM packets can give some issues because in case you lost OM packets or in case the OM packets get reordered, you cannot divide precisely traffic blocks. Instead, the alternation of traffic marking is very simple. So, no. Okay. This is just to give you a look of some RFC 8321 application in IETF. So we have some use case in beer, in Geneva, NSH. As I mentioned before, the use of RFC 6374 with the alternation of the synonymous flow label for the application of marking method. There is also a variation of the alternate marking in quick protocol. That is the spin bit application. Okay, this is some few words about how we can use the marking method to measure the delay. So the single marking method is based on the use of one bit that can be changed. And regarding the packet loss, I mentioned before how it works. Regarding the delay, we can use the first or last packet of a batch as a time reference for our delay calculation. But okay, this does not work in case it's sensitive to packet loss and packet reordering, because if the first packet of your batch get reordered or has been lost, the same packet is not the same for the next router. So you can have this kind of problem. An alternative could be to use the average packet delay calculation that can be done by calculating the average timestamp for each batch, and by comparing the average timestamp between two measurement points, you can calculate the mean delay, the average delay. Also, average delay variation is possible. We would suggest to use the double mark method because can avoid some packet loss and out of order issue that we have with the single mark method, because we use the L flag to create the first marking batches for packet loss calculation, and you use another flag to select some set of special packets that are dedicated for the delay measurement. So these demarked packets are fully identified over your network and can be used for the delay calculation. There is also a variation of this methodology that is called multiplexing alternate marking, that use the 0 flag in 1 bit batch and vice versa. So in this case, you can use the previous bit in the current batch. But the problem of this method is that you need 2 bits. Okay, the multiplexing variation, you need just 1 bit. So in general, we can consider the use of 1 bit or 2 bit, depending on the case. Okay, what about IPv6? Okay, each of the layers is responsible of its own OM. So we want to introduce this methodology for IPv6 because as a Telecom Italia, we have experimented this methodology for IPv4. We want to experiment it for IPv6. And we wanted to understand together with the working group how we can apply this to IPv6 scenarios. So we find some alternatives to apply the methodology by using an extension header, by using IPv6 address, and also by using the follow labels. Each of these alternatives have some pro and cons. But okay. For example, if you want to use an extension header to include the marking field, we should use an existing encapsulation header, or we should reuse, or we should define a new encapsulation header. But having an encapsulation header seems to be expensive because we need just 1 or 2 bits to apply this methodology. The same if we want to use a destination address to encode this methodology. So we can consider this also expensive and not so much compatible with the existing application. The other suggestion is to use the flow label field when we can, okay, you know that RFC 6438 introduce a flow label based load balancing, but we want to ask for just 1 or 2 bits of the flow label field to encode these methods. We got some discussion on V6OPS mailing list. Okay. Okay, there are some points of discussion that were raised. For example, regarding the flow label application, if we want to use 1 or 2 bits, does 18 or 19 bits be enough for the entropy? So this is a first question that we should address. Could the flow label be overloaded? So because it will be used both for marking, both for OM and for entropy and for load balancing. We should use an op-by-op or destination option extension. Otherwise, we can add this marking field to an existing encapsulation header, or we can define a new one. It's better, in my opinion, to reuse an existing encapsulation header, because if we need just 1 or 2 bits, it's not so useful to introduce a new one. There is also another possibility to use an extensible encapsulation that we are also working in MVO3 to introduce 2 bits for marking. So this can be also reused in IPv6 scenarios. And okay, the other point was about the intended status of this draft, that can be standard, informational, or experimental. So there is some discussion also about this. As a next step, we want to find an agreed solution for the application of this methodology. We want to add a multi-point use case that is a work in progress also in IPPM, that we want to extend also to IPv6 scenario. Okay, and question and comment are welcome.
Okay, let me ask some questions here. When you say adopt by working group, is that V6OPS, 6-man? Who do you want to adopt this?
Okay, we first present this draft in spring, then in V6OPS. I think that this can be the right place, but we should have also another presentation in 6 months. So
right.
I don't know. I want also your suggestion about what is the right place to move forward.
Okay, well, I believe your conversation in 6-man this afternoon will be about where to put the bits. Yeah. So I would suggest we defer that discussion to 6-man. Here, the real question is operational issues. So, Tim?
Yeah, Tim Chan. So I read or scanned through 8321 just now. That seems to be an experimental RFC, just probably worth noting that, rather than a proposed standard. And it seems that the only implementation you have, or the test you've done, is with using DSCP within a single domain. So again, just for the context of what we're discussing here. And I think, yeah, in 6-man, the obvious concerns will be that the revised flow label spec says, I think you can only set the flow label to essentially a random per flow value if it arrives with a 0 value. So I suspect lots of hosts are already setting flow labels, so your ability to remark that may be limited. And then there's the obvious extension header insertion questions that will come up. Yeah, in principle, it could be useful, but I think it's worth bearing in mind the status of this RFC at the moment and its limited deployment so far.
Thank you. Yeah, there is this experimental, but there are also some applications that are really for example, I mentioned also the application to MPLS that I know that some vendors have implemented this for the RFC 6374 improvement for MPLS. So.
Lee Howard, as co-chair, part of the operational question, I think, is this interesting work that would be operationally useful? Are there operators who would implement it if this was if the alternative marking method was available somewhere in a packet. If there are people who think that would be interesting, and I've heard of use cases, but I haven't heard of anybody saying, yes, I would like to measure my network or measure my performance in that way. And that could be, that doesn't have to be network operators. That could be endpoint, developers too.
Well, I could be completely mistaken, but I think Telecom Italia is interested.
Well, that would make sense. Since he's here, yes. But that's one.
Okay.
Thanks for the lead in, Lee. I'm not quite quick enough. As an enterprise operator, yes. Now, the devil may be in the details, and you're sitting right in front of me, so I'm going to talk to you more about this later, about how we would implement it. That would make a big difference to me. But the general capability of this information would be very valuable to managing our networks. Thank you for the work.
Thank you.
So, Mikhail, did you catch his name? Yeah, okay.
Mike Ackerman.
Yeah. Okay. Other comments? Okay, so.
I suggest we defer the adoption call.
Yeah. We need to have the 6-man discussion.
Okay.
So, okay, thank you much.
Thank you. Oh, thank you. This button does it?
Huh?
This button does it?
That button doesn't do anything that I've noticed.
Oh.
There's a version of this that has a light, they have the same button, but it
That button
should go
does it.
back.
Okay,
It goes
excellent.
back and forth.
Okay. Ron Bonica, hatless, penniless. The title of this draft is IP Fragmentation Considered Fragile. It used to be entitled IPv6 Fragmentation Considered Fragile, but one of the co-authors, Bob Hinden, pointed out that most of the criticisms we raise against IPv6 fragmentation are equally applicable to IPv4, so we made it slightly more general. So, what are we here for today? First is to point out that fragmentation is a bit fragile, talk about how fragmentation works, why it's fragile, and then come up with some recommendations. Now, about 6 years ago, I wrote a draft recommending that we deprecate fragmentation. We're not trying to do that today. We can't deprecate fragmentation. But what we would like to do is point out the problems and encourage protocol developers to wean themselves off their dependence on fragmentation. Make them use it less and less and less, so the problems will be less and less evident. It's not about deprecation, it's about weaning the community off of fragmentation. So, there are a couple terms that we need to know before we can even have the conversation. We need to know what MTU is, we need to know what the minimum link MTU is. Everybody knows for IPv6 it's 1280. Everybody is probably shocked that for IPv4 it's only 68. It's not 576. We need to know what path MTU is. And I assume everybody here knows all that stuff, so I can just skip over that slide. Now, how does fragmentation work? Well, we talk a little bit about it for IPv4 and IPv6. It's defined in the base draft for both of them in 791 and in 8200. The big difference between them is in IPv4, you can fragment at the source always, or if the DF bit is clear, you can fragment downstream. In IPv6, you can only fragment at the source. There is no DF bit, and if it were there, it would be assumed to be clear all the time. There is one. Well, yeah, sorry, I said all the time. Jet lag. There is one thing that IPv4 and IPv6 fragmentation have in common. When you get a packet and you fragment it, you'll see the upper layer header in the first fragment all of the time, always for every fragment.
you will never see the upper layer header in the second through nth fragments. You'll never see it in the subsequent fragments. That is where about half of the problems come from. Whoops. Okay. Let's go back a minute to the statement we made about where fragmentation can be done in IPv6 or in IPv4 when the DF bit is set. It's always done at the source. Well, if that's the case, the source has to do one of three things. First, it has to be, one option is it can be really conservative and never send a packet bigger than the minimum link MTU. That way it will never have to fragment. That's one thing you can do in IPv6 or in IPv4 when don't fragment is set. Another thing you can do is let the IP layer keep track of what it thinks the path MTU is and try to stay beneath that. That's the PMTUD discussion, which we'll have in this slide. Another possibility is to pass the responsibility up to the packetization layer and let either TCP or SCCP or whoever at a layer higher than IP keep track of what the PMTU is and let it refrain from sending packets too big. So let's talk a little bit about PMTUD first. How does it work? The source makes an initial estimate of what the PMTU to a destination is. Generally, that estimate is the MTU of the first hop towards the destination. That estimate may be large, but it's the best you can do a priori. Then the source starts sending packets, and one of those packets is going to be too large. When that happens, the router that had a hard time forwarding sends an ICMP packet too big back upstream. The PTB message has the MTU of the link you could not forward through. The source receives the ICMP message. It refines its estimate of the PMTU. This works really well if the network is capable of sending that ICMP message back upstream. If the network is not capable of doing that, it's black hole time. Okay, there was another option. If you don't want to rely on PMTUD and those ICMP messages, another possibility is packetization layer PMTU discovery. In this case, an upper layer protocol, say TCP, starts out, it makes an initial estimate of what the PMTU is. Then it starts sending probe packets to its TCP peer of various sizes. So it's padding the packet, so it'll be bigger or smaller. And it discovers the PMTU that way. And every once in a while, it probes around to see if its PMTU is too low, or it looks for lost packets to see if it's too high. Essentially, what it's doing is pushing the problem of PMTU discovery up to the packetization layer. And rather than relying on it, well, it can use ICMP feedback if it wants to, but its basic feedback is acknowledgement of its own probe packets. So we kind of know the state of the world now. So I said IP fragmentation is fragile. Why did I say that? If you go back to that first slide, the transport layer header is only in the first fragment. This messes up a few things. The first thing it messes up is a load balancer. Many load balancers try to load balance on things that are in the transport layer header, and if they're not there, you just can't load balance as effectively. Another possibility is firewalls. A firewall filter may filter based on something like a TCP port. If you're a stateless filter, you're not reassembling the packet, you can configure your firewall filter in one of two ways, too permissive or too restrictive. Either way you go, you have a problem. Either you let in every subsequent fragment, which is too permissive, or you don't let any of them in, which is too restrictive. Then there are other middle boxes that have the same problem. Let's say your middle box is trying to, say, update a diffserv code point based on the TCP port. Well, how do you do that? if the TCP header is not in the fragment. Hello. Oh, there we go. Okay. Now, there are also some well-known security vulnerabilities around IP fragmentation. And they've been documented for years. One of them is the overlapping fragment problem. You send two fragments, they overlap. Looked at individually, they pass the security policy, but when you reassemble the packet, one fragment overwrites another and you have something that wouldn't have passed the policy. Yes, you can prevent that by reassembling correctly, and there are RFCs that talk about how the correct reassembly should be done, but the firewall can't help you with it. You're relying entirely on the host that's doing the reassembly. There are resource exhaustion attacks like the Rose attack. We all know about those things. Another interesting problem is black holing due to ICMP loss. And I see Jeff Huston just walked in. He pointed out there are a couple of reasons for black holing due to ICMP loss. One is just somebody filtered ICMP. And that's a bad thing. They shouldn't. There are RFCs that say they shouldn't. But there are times when you have the problem and you can't prevent it. For instance, let's say for a moment that I'm a DNS client and I send a DNS request to a server and I send it to an Anycast address. It goes through just fine. The server responds with a great big response, and its source address is an Anycast. It has a PMTU problem, and it's relying on ICMP message. An ICMP message gets sent to the Anycast address, and unfortunately, it's delivered to a different DNS server than the one who sent me the packet. Black hole time. Another problem is one that both Fernando and Jeff pointed out, that for some reason operators tend to filter fragmented packets. We don't know why, but they do. So given that we have this known fragility, what do we do? Well, one thing we can do is push the problem up to the transport layer. Now for TCP, that's done. We have PLPMTU, and it is defined for TCP, and it works, and that will get you out of the problem. You won't be relying on fragmentation. For some other protocols, SCCP, DCS, I'll get it right. There's a draft Fairhurst that's working in the TSV working group that's hitting a bunch of other protocols. I hear that there is another draft in TSV talking about a way to do fragmentation at the UDP level. So UDP will be able to fragment and won't rely on IP fragmentation. All that stuff is good, and this draft is encouraging that, if not mandating it. Click. Thank you. So what are some recommendations here? Well, first is application developers should not develop new protocols that rely on IP fragmentation. If you develop them, they're not going to work in all environments. Second, this is just a repetition of another RFC. Operators should not filter ICMP packet too bigs. Notice I do not say that operators should not filter fragments. They do that now, and they probably do it for very valid reasons. I just stay away from that point altogether. And the meta recommendation here is that DNS, particularly when DNSSEC is involved and you're sending long responses, that needs a solution. It's critical to the internet architecture that DNS doesn't hit the fragility that IP fragmentation causes. Now, the next slide I'd like you to ignore. No, actually, no, I don't want you to ignore it. I do want it to be adopted as a working group item, but not here. I want it to be adopted in the internet area. Okay, and I see a queue of friendly faces at the line.
And I'm actually going first. Michael Abrahamson. So the network operator recommendation, I think it should actually say you must configure a network to make path MTU discovery work. That recommendation is not strong enough when it comes to, because there are plenty of scenarios where no ICMP is ever generated at all. It's not about filtering it.
You're right.
There are setups where the IC message is just, I mean, if the MRU is small enough, the NIC driver will drop the packet. No ICMP will ever be generated.
I didn't think about that. Some people don't even send them.
Yeah. So I think that, and I've helped people with IPv6 that have PPPoE tunnels, where my deduction was that their operator never generated a PTB at all.
You're right. I didn't think about that. That'll be in the next version.
Right. And also, I perhaps we should actually state about protocols doing PMTUD. I don't know if you just rely on the other draft to do that, but we could include that as well here. I don't know.
Okay.
Thank you.
West George. We have an elephant in the room. It continues to be an elephant and it continues to not get discussed. But saying that we shouldn't develop applications that rely on IP fragmentation is kind of the tail wagging the dog, in that the real problem here is that we can't carry packets that are big enough, because we still don't have an MTU larger than 1500 officially. Yes, we've got plenty of places we can do jumbo frame, but we are technically in violation of the Ethernet spec when we do that. And while I am not suggesting that any sort of formal change there will actually fix the MTU problem, it will help to reduce the areas where using larger than lowest common denominator MTU might actually work, because it will be more consistently supported. So I'd like to recommend, once again, and again, this is something that isn't specific to this working group, but given that you're talking about taking this draft to a larger discussion anyway, there might need to actually be the liaison statement to IEEE saying, please to fix this. Again, still, the rest of the world has moved on without you. You'd at least maybe make it official so that we can make this work better, because that's the fundamental problem here.
Okay. I agree with that.
Jared Mach, Akamai. So I had one comment and then Wes stuck a second one in my brain. But I'll try and stick to my first one. So the reason why I have often seen many fragments on the internet, and I've seen people filter fragments on the internet, is primarily around UDP amplification reflection attacks. So when somebody goes and injects a packet in, and then they get a very large response back, the application the application is sending all of this data, and the kernel ends up fragmenting all of that data. And the majority of fragmented packets, not all of them, but the majority of fragmented packets that people see tend to be involved in an attack.
Which is why they filter them?
Which is why they have filtered them historically. So,
let me ask you a question about the attacks.
Yes.
If the UDP header had been in each fragment, would it have been more obvious which fragments were parts of attacks and which ones were parts of legitimate traffic? Would they be less likely, if UDP could fragment, would they be less likely to shoot all fragments?
Yeah, if the port number were not 0, it would be very
Oh, yeah, okay.
Yes, first I'd like to second what Michael said. Your draft currently talking about network not delivering ICMP, while what I'm observing is some router vendors have some rate limits on generating those ICMP packet too big, and as a result, yeah.
Yes, in fact, that rate limit can be blamed on RFC 1812 or 19.
I didn't write it, I edited it.
I think we should maintain no blame policy, right? Let's just get things fixed. So yeah, we need to explicitly say that it's not just filtering, it's other things when ICMP is not generated. Secondly, as an operator, I filter packets which I do not need. And if I need DNS, I would happy not to filter DNS, right? So I believe maybe it would be a nice recommendation to say network operators that they might consider not filtering fragments to and from their DNS servers.
Well, how would you?
Okay.
Okay, you know it by
It's
address.
quite well-known scenarios when some networks have their own DNS server their clients using, right? And they know what those addresses are. It would not completely fix the problem, but it fixed part of it for a significant number of users. So I think it might be nice recommendation there, not just, okay, because honestly, the main problem is DNSSEC, right? I do not care about ISPF. ISPF is running within the network. I normally control MTU, and to be honest, I have never seen, my experience may be limited, but I've never seen problem with MTU and ISPF except for misconfiguration.
I'm sorry, did you say MTU on OSPF?
Because I think you mentioned what is the second protocol which suffers from
Okay,
this.
yeah, OSPF doesn't really have the
Yeah.
problem because most implementations keep the packet small.
Yeah, so DNSSEC is the real problem.
Yeah, he's the-
Yeah, and again, we know most operators do not know at least some of the DNS IPs that they might consider not filtering, right? So it might be a recommendation here as well.
Okay.
Julius Krobacek. So thank you very much. So as you mentioned, you repeat a few things that are in other RFCs and in other documents, but that could be a very helpful document because we keep seeing people who rely on fragmentation in their protocols, and it would be very helpful to have a document that you can show and tell people, look, I'm not going to explain it to you because some wiser people than me have explained it very well in this document. So I think it's a very good idea.
Thank you.
I do have some editorial comments. So one is that I'm not quite sure. So perhaps the least important one is I think you don't insist enough on the issue of efficiency, on what happens when some some fragments are destroyed by an AQM and others are not, so they become useless. I don't think it's a significant problem, but it's something that speaks to people's imagination. And so it might be worth stressing that a little bit more.
Okay.
And the other point is I have the feeling that it's not quite clear who you're speaking to. Are you speaking to network operators or to application programmers? And what I'm concerned about are application programmers because I think that network operators are very wise people and they don't have this problem.
Going.
Excuse me. So I would like to see it more aimed at application programmers, and I would like you to say outright from the beginning, look, mate, if you're doing TCP, you're fine because TCP will do it for you. But if you're layering your application layer protocol over UDP, then it's your duty and you will burn in hell if you don't take care of this particular problem.
I like
and
that.
I'd like this to be a little, said outright that you are blaming the people who are doing UDP. And I feel that's not...
I kind of like changing the emphasis that way because if you look at the recommendations, I'm saying nothing new to the operators, but I'm hitting the application developer over the head with a stick.
Exactly my point.
Yeah, burning in hell might be a bit severe, but...
Okay, formulate, it's your document, so perhaps you don't have the same style as me.
Okay, Christian Wiedemer, independent. I have basically some personal experience. I send that to the list, actually. One thing you don't mention is that fragmented packets do not arrive in the same order as the packets that are not fragmented.
That's true. It takes time to reassemble and they get out of order.
No, actually they arrive before. So we are doing that, doing a quick interrupt test. And during the quick interrupt test, one of my colleagues with whom I was trying to interpret tells me, hey, why are you sending the encrypted packet before the uncheck finished packet? Because, I mean, the encryption key is in the uncheck finished packet, and then you send encrypted packets.
Yeah, that's shocking.
Yeah, that's bizarre. I'm not doing that. But it turns out that my first encrypted packet was an MTU probe to see, can I send that long on the message?
Oh, I get it. Yep.
And then what happens is that something in the path, it's probably some thing in the Linux kernel, it might have been a first hop router, decided to split the packet in two because that MTU probe was obviously too long for the network. And so the first half of the and when they do that, they actually do some bizarre things. But long story short, because they don't have the same port numbers and all that, they don't go in the same hash buckets in your load balancers. And because of that, they can very well arrive before the other packets. or after or any time in between. And so that's one of the things that you might want to mention there.
Yeah.
And then you have also the fact that guys like me, it's well to say that application layer providers shall not depend on IPv6 fragmentation. We don't. In fact, we don't want to. But have you observed that there is no such thing as an IPv6 don't fragment bit in the header?
It's on by default. Yeah,
It's on by default, and it's then ignored by default by your kernel or by your home gateway. No, it's not the API. It's not the API. No, I can disable that on Linux by using the API, and I am doing that now, clearly. But I cannot disable that on the home gateway. Oh yes, I do. Oh yes, I do. Some do, absolutely.
That's a violation of the standards, right?
You know, I'm programming on the network I have, not the network I wish I have.
Maybe we should.
Okay, guys, I need to remind you that we have half an hour left and we have a couple of more presentations. So let's be a little succinct.
After years of observing the lack of success of BCP38, I actually think that there is not much hope in trying to fix structurally broken problems. There is no doubt right now in the V6 network, the chances of getting a fragmented packet through the network, for whatever reason it got fragmented, to any arbitrary destination, your chances are about 60% success rate. And in V4, your chances are still only at 80%. And I don't think we can fix it.
There's empirical evidence to support that.
So all the whips in the world, all the castigation and so on won't fix it. So what does that mean? For TCP, as you said, a good TCP will actually try and work within parameters that don't require fragmented TCP. And in theory, one should never see fragmented TCP packets. Certainly in V6, because it can't happen on the fly, you should never see it. What about UDP? And again, someone said, you know, it's the DNS. And that's true, largely, that the big packets and DNSSEC go together. Now, the DNS will fix that after a while. It probes and probes into timeouts. But if you really thought, God, this is going probably not to make it, wouldn't you immediately fall back to TCP almost at once in the application protocol? In other words, rather than thinking that fragmentation loss is a rare event and it will take me some time to test, shouldn't you immediately say, well, I'm going to send a fragmented packet, but then I'm going to trigger the DNS to go to TCP as soon as I can? And so over in DNS ops, in theory, they should be looking at a draft by Davey Song that suggested whenever you fragment, send an additional gratuitous response packet that is your question with the truncate bit set. If you don't get the frag, within a couple of milliseconds, you'll get the trigger to go to TCP and avoid the fragmentation problem. I like that thinking, because once you get to the room of it ain't going to ever get fixed, let's live with this, you then start to think about how can I make the flip of fragmentation loss to recovery much, much faster than the banging the rocks we do today.
So I think what you're suggesting is that the recommendation to the application developer shouldn't be don't ever, don't rely on it, it's okay, but we are, maybe we give some nuance to that. That's saying
if you must fragment, and DNS feels it must because
be
DNS
ready,
over TCP
be
is
ready to
Armageddon.
recover.
When you fragment more quickly than what you're doing now.
Yeah.
In other words, assume
It's going to break and recover immediately.
Break and recover. Yes, that's much more pragmatic.
So actually, DNS doesn't depend on IP fragmentation. eDNS 0 allows the requester to specify the length of the packet.
No.
Yes.
But a massive digression. Don't want to go there. But Fred, no.
Jared Mach from Akamai again. So I have a kind of similar theme of what Jeff was talking about, which is that, and you know, Wes brought up earlier of let's just make really large MTUs, really large MRUs on the internet. so we can pass all of these really large packets. The problems that I've seen here are that the router vendors tend to do this very poorly. In stuff, we have the rate limiters that were previously mentioned as well, that go and cause these packets to not necessarily be generated back, so the hosts understand what's going on. But I have to say, most importantly, the end users and the performance expectations that they have in running a CDN. Our end users, our end customers, have really high performance expectations. The extra couple RTT to go and do a PMTU event is something that is something where we would rather go and do something else instead in order to ensure the end users are getting the performance necessary, regardless of whether or not the application is DNS or Memcached or anything else that is cool and sexy today. And performance is really going to be the gating thing. And we've seen that in how Happy Eyeballs was implemented with the very tight timers and so many milliseconds. And so something like this needs to absolutely work within those boundaries of what the performance expectations are for a modern internet, and trying to discover a L2 MTU black hole, because somebody's switch is misconfigured wrong or routers misconfigured wrong, is really something that is many people are, advanced operators are going to find, but many of the less sophisticated operators are going to have a huge time debugging that.
Yeah.
And that's a big concern.
I think between you and Jeff, what we've just figured out is that we need more nuance to that recommendation to application developers. Just saying don't do it isn't good enough. That's like, just say no to drugs. We have to say, try not to do it. If you have to do it, have some recovery mechanism. And by the way, the recovery mechanism has to perform well.
Lorenzo, clearly, I don't see that the usefulness in that guidance. I just, if it's broken, then just move away from it. Like realistically, there's really nothing we can practically do to fix this problem. And we might as well be looking at packetization layer, the transport layer solutions for fragmentation, right? An extra UDP header, or just putting the solutions into the protocols that need them. I mean, we can pretend that 2,000 byte packets will survive on the internet. Fact is that they don't, right? So, I mean, for DNS, again, how's the client, because the client's the one that needs to fall back to TCP, right? How does the client know if the response is going to be too big? Do I try it every time, right? Because it's, yeah. So I think that's actually reasonable guidance. It's basically, and I think you get bitten by packet reordering, all this stuff. We just need to say, look, but one thing that we got when we were implementing 464X, which also has fragmentation issues, right? Was Ike assumes that you can send a certificate in a packet, and that's just silly, right? Huh? Sorry? Oh, okay, Ike v1. Sorry. Okay, but my point is, I think even protocol developers, right? We should stop assuming that fragmentation is going to work.
Yeah. Well,
so it's not just application developers.
I'm going to try to sit on the fence without hurting myself. On the one hand, we can make this more nuanced guidance. On the other hand, if we just leave the guidance the way it is, people who are actually experts will fix the problem. And we need to find some. Jeff is shaking his head no. Or they might not. So we need to work that problem. That's probably for the mailing list.
I'm Jim Metatia. Some quick notes about DNS. Probably you already know that, but there's a trend of doing TCP for DNS more aggressively. So that may be related to this fact. Although I don't think DNS over UDP will disappear pretty soon. And secondly, there's a proposal of doing the application layer fragmentation for DNS several years ago, and I think it's dead, but if you are interested in it, I'll send the link to you.
Yes, please.
And finally, Jeff is right, eDNS 0 doesn't solve this problem.
Thank you. And thank you all.
Okay, Jordy, we've got about 20 minutes, so sorry.
Sorry.
Does this impact?
Yep. Okay. So, history of this document. there was a discussion in the IETF mailing list a while ago about deploying just NAT64 in the IETF network. I was suggesting instead of that 464XLAT. The main discussion was that DNS64 breaks DNSSEC. And 464XLAT can be used without the need of using DNS64, which is something which is not possible with just NAT64. So I documented that and presented in the previous meeting, and the working group suggested that the document should be an overall discussion of deploying NAT64 and not just 464XLAT. So that's what we have right now. So the summary of the document contents is speaking about the three main issues of NAT64 deployment, which is that NAT64 with DNS64 breaks DNSSEC. NAT64 and DNS64 don't work for literals and older APIs. And NAT64 is not solving the problem of IPv4 only host. So then the document goes into discussing the considerations regarding DNSSEC. And I decided to take an approach of looking if I am an ISP or an enterprise, because even if I was at the beginning focusing the document in ISPs, I decided at the end, when the document was already done, that it works the same if I am an enterprise having my own NAT64, like the case for the NAT64 in the IETF network, right? So I decided to look at the approach of what wants to get an operator when they are deploying NAT64. They want to make sure that everything works. So I look at the perspective of the different scenarios, trying to see if everything is going to work in each of those scenarios. And the scenarios basically look into considerations about how it works depending on where is located the NAT, the DNS, and if there is or not a CLAT. Okay, so that's the way I have looked at the scenarios. I don't have time to go through all the scenarios, so I didn't put them in the slides, but basically the idea is you can have an operator that have everything in their own network, or maybe the case, and it happens already, where people is using an external DNS, and that means they can use an external DNS64, and this is something available already today. Or we can have somebody, instead of using their own NAT64, having a third-party operator for the NAT64. Okay, so those are the different possibilities. And again, I am not going to go through, but I think at the end is something like 6 basic scenarios. So then I go into looking into possible workarounds for the main problem, which is breaking the DNSSEC. And the workarounds are basically either not using DNS64, and then I look into each of the scenarios if that is going to work or not. The DNSSEC validator is aware of the existence of the DNS64, a stub validator, CLAT with DNS proxy and validator, ACL of clients, mapping out IPv4 addresses. And then another thing I am looking is considerations regarding the reverse mapping for DNS64. And then I look into the issue regarding the IPv4 literals and APIs, all APIs, IPv4 only hosts or applications. Then I look also into the possibilities and pros and cons of using a CLAT, more than 464XLAT, a CLAT, or a network with a CLAT using or not a DNS64. Then I look into something which is very common today, which is most of the customers don't use the DNS provided by the operator. They use their own 8.8.8.8. So is that going to work? And what are the consequences in each of the scenarios? Okay, so then CLAT translation considerations, summary of deployment considerations, and also I have a section regarding IANA consideration, because there is, I think it was Mark Andrews who submitted an amendment and also recommendation from IANA for the IPv, I think it was the IPv6 only.ARPA or something like that, which is used for the automatic discovery of the DNS, of the NAT64 and so on. And in the case that errata is not, let's say, moving through, I will need to have that in the IANA consideration section, right? And I think that's it, basically. I'm not sure if I did in time, probably. I have something like 5 minutes for each presentation, right?
Yeah, so why don't we run through your presentations very quickly, and then we'll just take the whole lot of the mic.
So next one.
Okay.
Okay, so similar situation here. I presented this document long while ago. Actually, I started to work in this in 2006. And the basic idea of the document at that time was we can use the part of the customer prefix. For example, if the customer has a /48, we can use the first /64 for the point-to-point link. Actually, when I did the slides in the previous presentation in Singapore, I make a mistake here. I said that 31% of operators were using that. I took the wrong number. It's actually 69% of operators who answered my survey, and I got already more than 1,600 answers. So it's a big representation of who is deploying IPv6 worldwide using that. And there was also a document from the HCPv6 prefix delegation in 2012, which is actually supporting the way to do this. Okay, so in the previous meeting, not 101, it was 100. The working group told me basically, instead of working in only this, why you don't broaden the scope of the document to look into all the possible ways to deploy the point-to-point links. So that's what I did. Summary of the document is I start refreshing about 6164. This is recommending somehow using 127, but it's not actually saying it's the only way. It's more a recommendation for router vendors to make sure that they support that, okay? Then I start talking about the different prefix size choices. So I review what it says in RFC 7608, which is basically is a parameter, the prefix length. So we could perfectly use /64, 127, 126, other choices, and also why not use allocate /64 and just use 127. Okay. There is actually a document that we developed in RIPE, which is RIPE 690, I think is the number, where we have actually looked into some of these issues, not all of them, but the document is also looking in issues that are not part of this document. So I just basically look at that document and follow what we have decided, and that document has authors from all the regions and got consensus from operators in all the regions. Then I look into numbering choices, like using global unicast addresses, using ULAs, using unnumbered. I look also into prefix pool choices, like we can just use, like we typically do in IPv4, a different pool for the point-to-point links, or we can use, as I mentioned in the first slide, a /64 from the customer prefix, and then I look into the details of that. Now it's stuck. Fred, can you? Yeah. If anyone has not seen the survey, all the numbers I have used, all the percentages I have used it in the document and in the slides come from this survey. I think the last version of my survey presentation was done here in London about a couple of months ago in the UK North. So you can find that complete set of slides. But these are the figures of what the people is using in terms of one prefix size, one prefix addressing type, and so on. I submitted on Sunday very early in the morning a new version. So now is 01 instead of 00. And these are the 3 changes I did. Basically, it's editorial text and some recommendations that I think it was Brian Carpenter sent to the list. And I think that's it. So you can go to the next one. Okay, this document has also long history. The first thing to notice is that it should be somewhere in the room. I have now a co-author. I asked it for the 3 documents. I asked if somebody want to contribute, and only in the case of this document, I got a yes from Hans from the link. So now he's also part of the document. This document was actually, the origin of this document was actually accepted as working group item in the IETF 1 year ago in Chicago. Basically, in that document, we had the broader scope. We were trying to update RFC 7084, with all the new transition mechanisms and HomeNet. I had a lot of versions, and then there was a pushback from the working group. And then in Singapore, I think I got the final recommendation from the working group, or at least what I understood looking at the video, is keep the format of RFC 7084, but use the document as an extension to that document. So take only in consideration supporting IPv4 as a service. So looking into, we will have IPv6 only access networks, and we need the CPEs to support that, okay? Basically the point, this is not working anymore. No battery, Fred. It takes time. I'm not sure where I am right now. Okay.
So I think you want this one. Which one do you want?
The third slide. After the title, one and another one. It's moving along. I am not doing anything.
Yeah, well, that's because I'm moving it based on what you're telling me. But
okay.
You need to be clear.
I think it's that one. Okay. So the point is clear. We don't have any more IPv4 addresses. People, the ISPs are not able today to say to the customers, I only provide you IPv6 and I don't support your IPv4 devices in the network. There is no way an ISP can do that, okay? I like it very much, the presentation that we have about hosted services, but for broadband services, the situation is totally different. So we cannot go, unfortunately, that way. So the basic idea of the document is working over that. The CPEs need to support IPv4 as a service. We will get, in the next few years, IPv6 only access networks. In some cases, for example, all the deployments with DS Lite, this is the way we are doing, and we have IPv6 only one, but we still need to support IPv4 inside of the customer LANs. I have been talking with CPE vendors for about 1 year or maybe 1.5 years since now, and most of them told me, well, what you are saying, the document, we support it, but we don't have in the retail firmware, and we don't have it in the standard firmware. Most of the time we do in a project basis. So basically something that it's already done, but they are telling me we need a document that supports it to put it in the retail firmware. Okay, it's the only way we are going to go through that path. So summary of the document. Well, there is nothing new basically in the document. On the other way around, it's a cut down version from the previous versions. Basically, the document is looking only as an extension, so they must support RFC 7084, and in addition, using the same style as RFC 7084, if you want to support this transition mechanism, do this and this. If you support this transition mechanism, do that and that. I think Barbara actually said that from one of the previous documents. That was the scope of the document, and we just did the same. We make sure that following the recommendations of the previous presentation, we have a problem description, we have scenarios which were not clear in RFC 7084, we have end user architecture, which when the one is IPv6 only, but IPv4 is still needed. And we also explain the cost of code to support these new functionalities. And I think that's basically it. Yeah, that's it.
Okay, so comments on those three presentations, Jen?
Jen Linkova. Comment on, I looked at NAT64 document and I got totally confused because I read it as don't even try. It might be just me, but looking at your scenarios and the things and how you describe what's not going to work, you'll scare people away. And I do not think it's a fair approach because we do not know a number of scenarios when it does work, right? And regarding DNSSEC problem, I wonder if it's a time to look at this from another perspective and just clearly say, okay, if you deploy DNSSEC, you have to deploy IPv6. DNSSEC has dependencies. If you care about security in your DNS, you need to make sure you have quad A's in your zone. Done.
Totally agree with you.
No, I'm talking about actually as a necessary trans part, which also needs to be solved. But all this like, oh my God, we cannot deploy DNS64 because of DNSSEC, or we cannot deploy DNSSEC because of DNS64. I think it should be just a requirement. In addition to configuring all this stuff for creating all these keys in your zone, you also need to add quad A records. And I make sure V6 deployed, and that problem solved.
I totally agree with you. I think, and I believe I put that in the document. I think there is text speaking about that, but maybe I forgot at the last minute. But it has been always in my mind. I always remember that you did the testing few years ago, and I think it was 1.7 failures because the lack of DNS64.
Yeah, it actually depends on what DNS64 does because RFC was not clear and there are different implementations. But yeah, if it's only doing synthesis for signs, so yeah, if it's overlap between sign zone and zone without V4, yeah, it's about 1%. So it's actually much less than DNSSEC problem for V6 transport. So actually, who cares?
Let's assume that now it's 2% failures. It's the fault of the people deploying DNSSEC, not deploying IPv6. That's clear. That's clear. So that's an obvious recommendation.
Barbara Stark. I did go through the transition technology document. I think it's much improved. I like the approach. I am still concerned that there are still too many transition technologies. And I really think that somehow there needs to be a determination of, number of operators who actually want some of the various technologies and maybe somehow try to weed them out a little more. And of course, you mentioned that you wanted to try and get it in the CE router testing that's done by UNH-IOL, but that you need to talk to Tim Winters or...
We talked already.
Yeah.
Lee Howard, this is not a comment as a chair. I have been, or a few of us, I think I had the idea and several people have contributed to a listing of operators who are running various transition technologies. I owe AP Nick a blog post on this, and I've been trying to actually get it written, but I will send that list to the V6 ops list so we can at least get a sense for who's running which transition mechanisms. I will note that to my knowledge, no major operator is currently running MAP. I think that is not because of a failure in MAP as much as it's a newness of MAP. Both T and E, I think, are of interest. I do know of one large operator, actually Charter in the US, has announced they're an early field trial for MAP-T, but that's the only one I know of.
Well, now JP&E is running MAP-E. They gave a presentation in V6
3 years ago. Yeah. Right, I've forgotten about that. Yes.
And Reliance JIO is running MAP-T.
Are they? Okay. I'm going to
That's
go
what they
update
said.
I'm going to go update my spreadsheet.
That's what they said. So.
In the survey I mentioned before, one of the questions was which transition mechanism are you using? And it's true that Lightwave 4/6, MAP-T, MAP-E were those less used, but in the last couple of years I heard about more and more deployments of, and I am talking about big deployments, about Lightwave 4/6. And of course, if you consider also the cellular world, 464X-LAT, it's probably the transition mechanism which has bigger deployment. Trying to reduce the number of transition mechanisms when I have only 4, I think it's difficult. But in addition to that, it's not a recommendation to say you must support this and this and this. Is following the same approach as RFC 7084, which say, if you want to run this, do this. If you want to run that, do that. So it's not at all stating you must support all 4. And in addition to that, and that's what we have the code consideration section, all the data plane among all those transition mechanisms is exactly the same as the slide, which is already in RFC 7084. So there is nothing new in terms of code.
Okay, so we're now at the top of the hour and we have a problem. So what I'm going to suggest is that we take this to the list. I'll basically invite comments on the drafts and try to focus attention on it. Where are the blue sheets?
Thank you.
So they're back in the back of the room there. Okay. Anybody that hasn't signed in, please put yourself on the blue sheet. Okay. I guess I'm jet lagged or something like that. Right. Okay, so then we're adjourned and we'll take the rest of this to the list. Sorry? Right, and where is that? Victoria.
Pointers, I was looking if I had a USB extension cable so you could put the receiver a bit closer to them. But I didn't have it with me.
Yeah, well, I've got one upstairs. It's probably this long.
No, you need 2 or 3 meter one.
This is actually, maybe I need to change the battery.
Yeah, two different ones. They're doing the same. I've noticed as well, if a lot of people have Bluetooth and Wi-Fi all that enabled, those modes just lose connectivity. I was thinking maybe you should move your receiver a bit more that way.
Well, except that was over there, so.